Good afternoon, sir. Vasco. So, I am JR Migatuan from base MT2 section Metal Gas. So, in this video, I'm going to explain my answer about the CO1 about the echo sounder. So, this is my task 1. So, explain through illustration the operating principle of how echo sounder measure the depth below transducer. So, this is the ship, the transducer, the propeller, and the transducer is inside. So this is the transmitted pulse. So the return pulse and the single beam echo sounder. So this is how it works. So the recorder is on the ship. So pulse generator like this. Pulse generator of paubos. So transmit, so transmit padung ubos, transducer kani mo ka nasa sibid na padung sa sibid, tapos receive, pag receive mo return siya mukha sa amplifier, tapos diretso na sa record. So this is how the echo sounder measure the depth below using by the transducer. So on task 2, explain through illustration formula of how the depth below transducer is being calculated. So mo yung ship, mo yung sea level or the water surface. So the transducer. So it transmit and return by acoustic pulse, and it measure depth of function of pulse travel time travel of time pulse paubos, tapos pulse velocity in water with v by distance, the distance of seabed and the transducer or the ship. So distance equals v times time or velocity times travel of time over 2. So mo tay pag measure sa kalawmon. So this is the outgoing signal, the reflected signal, and the reference. So this is how the formula of how the depth below transducer is being calculated. And the last task is the last number 3. So explain the 7 identified errors of echo sounder. So first is velocity changes of propagation in water. So the velocity of acoustic wave changes changes its temperature, salinity, or pressure changes, and since velocity is not correct, the depth recorded will be inaccurate. To compensate the error due to temperature variation, a component called thermistor are mounted near transducer to account temperature changes. And number 2 is Stellus speed error. The speed of Stellus is such that the time taken by the Stellus to travel from the top to bottom on chart is same as the time taken by the sound waves to travel twice the range selected, but due to the fluctuation in voltage supply to stylus motor will cause error in the recorded depth. And number 3 is a Pythagoras error. So this error is found when 2 transducers are used, one for transmission and the other one for reception. It is calculated using the Pythagoras principle. It is become prominent whenever distance between two transducers exceed 2 meters, manual guides are used for correction tables. So number 4, multiple echoes. The echo are reflected of many times casual occurring in shallow water. It generates multiple marks on paper due to number of waves recorded. In such case, the first echo is correct deep. Number 5, thermal and density layer. The density of the water varies with temperature and salinity, which all tends to form different layers. The sound wave may be reflected from these layers. So number 6 is zero line adjustment error. If the zero is not adjusted properly, it will give error in reaching. It must be adjusted to obtain accurate reading. The last is the erasure. When the sound wave is reflected from the reflected air bubbles, it will appear as dots. It is due to packets of bubbles from heavy weather. So that's all for my answer, sir. So I hope you will understand my explanation. So thank you.